Assalamu alaikum, my dear students. How are you all? I think you are all well by the grace of Almighty Allah. Welcome to NIVA Sumi School. I am Yamin Apu, an assistant teacher of mathematics, National Ideal English Version School morning shift. Dear students, I am going to take a higher math class today for the student of class 9. Our today's topic is Theorem-11. Okay, it's the theorem of Brahmagupta, and our lecture number is 2, and you have a homework. Your homework number is 2. Okay, now let's start the class. Your theorem is 11 we will discuss today. Okay, to prove this theorem we need 3 basic concepts here. Okay, I repeat, dear students, we need 3 basic concepts here to prove this theorem. We'll discuss it later, but first of all, look, it's theorem 11 is the theorem of Brahmagupta. Okay, a name of the scientist whose name is Brahmagupta, who stated this theorem. That's why this theorem's name is Brahmagupta's theorem. Okay, the theorem is, if any cyclic quadrilateral has perpendicular diagonals, then the perpendicular to a side from the point of intersecting of the diagonals always bisects the opposite side. What does this mean? This means that suppose this is a circle, okay, and a quadrilateral is drawn inside this circle. Okay, it's called the cyclic quadrilateral. Okay, it is cyclic quadrilateral, and the diagonals of this quadrilateral, this one a diagonal and this one is another diagonal. If these two diagonal are intersecting at the point of perpendicularly, if these two diagonal perpendicularly intersects, then what happens? Then the theorem will be from the intersecting point, if we draw in any side, if we draw a perpendicular from this point, from this intersecting point, if we draw any perpendicular line in any side, suppose in this side, if we draw the perpendicular line, suppose this is the perpendicular line, okay, this is M, suppose this is M, suppose it's E, M is perpendicular to this line, then if we extend this line in the opposite side, then this line will intersect at any point, it will be the midpoint of this side. Okay, so the theorem says that what? The theorem says that if any cyclic quadrilateral has perpendicular diagonals, this quadrilateral has perpendicular diagonals, okay, then the perpendicular to a side from the point of intersecting, a perpendicular from this intersecting point, that means ME, of the diagonals always bisect the opposite side. The diagonals in this opposite side will bisect this opposite side. That means this side will be bisected by this point. Okay, this is our theorem. That means we need to prove that this side is bisecting. That means this is the midpoint. Suppose this is P, then P is the midpoint of this line. Okay, we need to prove that. So this is our general enunciation. You can write down the general enunciation is the question. Okay. Now you have the special nomination, or you can write down the particular enunciation. Okay, you can write down here particular enunciation. It's also okay. If you write down a special nomination, this will also be okay. Special nomination is nothing but about the figure. The figure says that ABCD is a quadrilateral inscribed in a circle with perpendicular diagonals. I have write down here. Suppose this is A, B, C, D is a quadrilateral which is drawn inside the circle. Okay, and it has the perpendicular diagonal. What does this mean? This means then AC and BD bisect perpendicularly. Okay, at point M. This point's name is also M here. Okay, I'm writing down this point again. This point is M, and ME is a perpendicular on the side BC. I have write down ME is a perpendicular line on the line BC. Okay, this is a perpendicular on BC. From BC the point M and extended EM intersect the point, the opposite side AD at the point F. That means this point's name is suppose F. So the extended of EM intersect the point at F of the opposite side BD. Okay, sorry, AD. AD is the opposite side of BC. So if in EF intersect at BD at the point F. So we need to prove that F is the midpoint of this side AD, or we need to prove that AF equal to DF. We need to prove that what? AF equal to DF. Okay. So it is to be proved that AF equal to FD or DF similarly. Okay. Now I am going to prove this one. Before to prove this one, the proof is so small, but before to prove this one we need three basic concepts. The first concept is in any circle, if we consider any chord, suppose it's AB a chord on the circle ABC. Okay, on the circle ABC, AB is any chord. Then if we draw the circular angle or angle which is standing in this similar chord on the circle, then that's angles will be equal. That means if we draw the circular angle, this is circular angle, this angle, okay, this is also a circular angle, the similar chord, okay, this is also a circular angle, then all the angles will be equal to each other because they are standing in the same chord. That's why all the angles will be equal to each other. Okay, this is needed, very special concept we need here, okay, to prove this theorem. Another one is what? Another one is complementary angle. We know that the sum of complementary angles is how much? One right angle, right, or 90 degree. Suppose these are two complementary angles, this must be 90 degree, their sum. Suppose this is y, this angle's name is y, this angle's name is x, then x plus y is equal to 90 degree. If x plus y is equal to 90 degree, then we can say that x and y are complementary angle to each other. X and y are complementary angle to each other if the sum of the two angles is 90 degree. And another concept we will discuss later. No, I think I need to discuss is now. If in any triangle the two sides are equal, then the opposite angle of these two equal sides are also be equal. Opposite angles means suppose ABC is a triangle, then AB and AC is equal here. AB and AC are equal here. Then the opposite angles will also be equal. That means AB's opposite angle is what? ACB. So ACB, that's equal to AC's opposite angle is what? It's ABC. It's angle ABC. So if the side AB and AC is equal in any triangle, then these two opposite angles also be equal. That means angle ACB equal to ABC. Okay. Conversely, if the two angle is equal to each other in a triangle, then the opposite side also be equal. ABC is equal to ACB, then we can say that AC equal to AB. I hope you have understood. These three concepts we need here to prove this theorem. Okay. Now I am going to prove this one. We need to prove, my dear students, is AF equal to FD. Okay. To prove, first of all, we will prove in this triangle, these two angle is equal to each other. If we can prove that these two angle is equal to each other, then we can say that this AF equal to FM. Again, similarly, you can prove that these two angle, that means this angle and this angle, are equal to each other. If we can prove that these two angles are equal, then the opposite side, that means this side and this angle is this side is equal to each other. So FM equal to AF equal to FD. So we can say that AF equal to FD. Okay, like this way we will prove this one. Okay. Now the proof is start here. Suppose DC or CD is a chord here. Okay, and the standing circular angle, there are two circular angle which are DAC and DBC. Angle DAC, that will be equal to DBC, because these two angles DBC and DAC are standing in the similar circle and in the same chord. That's why these two angles are equal to each other. Okay. Suppose this angle's name is X, this angle's name is also X. Okay. So these two angles will be equal to each other. Another one is what? Look, my dear student, this is BD and AC are perpendicular to each other, right? So the angle BMC equal to how much? The angle BMC equal to, the angle BMC equal to 90 degree. Okay? So the angle BME plus angle EMC is equal to 90 degree, right? So the angle BME plus angle EMC that's equal to 90 degree, you can say. Okay, like this, another angle there will be, my dear student, ME. We have drawn ME equal to perpendicular of the line BC. So we can say that BEM equal to 90 degree. The angle BEM, the angle BEM equal to 90 degree. And in this triangle BME, in this triangle BME, one angle is 90 degree. That angle is BEM. So the sum of other two angle will be 90 degree also, because sum of three angle in a triangle is 180 degree. That's why if one angle is 90 degree, the other two angles sum will be 90 degree. That means this angle EBM plus the angle EMB that's equal to 90 degree also, right? Now my dear students, EBM we can write BME, okay? BME similar. Okay, now from these two equation, the students, from these two equation we can say that BME angles complementary angle, BME angles complementary angle is EBM. Angle EBM is the complementary angle of BME, and the angle EMC, the angle EMC is the complementary angle of BME. Okay, so BM is complementary angle is both of these one. So these both angle must be equal to each other, because this two angle is the complementary angle of the same angle. That's why these two angle must be equal to each other. Okay, that means we have proved already this one, this EBM equal to BME, right? So if this is X, then this angle must be X. Okay, sorry, this one will be. And my dear students, after that what we can say? Look, we can say that this EMC, the angle EMC is of alternative opposite angle. Okay, vertical opposite angle is AMF, angle AMF. So these two angle will be also equal to each other. This one, if this one is X, then this one is also be X. This is because these two angles are vertically opposite angle, and we know that vertically opposite angles are equal to each other. So we have proved already this angle is X, this angle is X, this angle is X, this angle is X. That means this two angle is X. That means we can say that FAM equal to FMA. We can say that FAM that's equal to angle FMA. So if in a triangle, if two angles are equal to each other, then we can say that the opposite side of this equal to angle also be equal. That means the opposite side of angle FAM is what? Is FM. Is FM. And the opposite side of the angle FMA is AF. AF. That means AF equal to, sorry, FM equal to AF. Similarly, my dear students, similarly we can prove that what? We can prove that the angle, the four angles, that means the angle FDM that's equal to the angle BCM. These two angles are standing in the same chord. These two angles in the same chord, that means on the chord AB, this two angle is situated. So this two angle will be equal. That's equal to what? That's equal to an angle BME, because this angle is the complementary angle of the similar angle. These two angles are the complementary angle of the same angle. Okay, and that's equal to, we can write down DMF. Why? Because these two angles are vertically opposite angle to each other. Okay. So this 4 angle will be equal to each other. That's why we can write down this angle equal to this angle. And that's why we can write down this angle is equal to this angle. So we can prove that we can, from these two angles, we can say that FDM and equal to angle DMF. Look at the figure. It's FDM equal to FMD. Okay. So these two angles will be equal to each other. That's why I can write down the FD is equal to FM. So from these two equations, these two sides, that means FM and FM equal to F, FM equal to FD. So you can write down AF equal to FD. This is our proof, my dear students. So look at the proof in your book. In your book, this says that because they are encircled angle that intercept the same arc CD, that means CD's similar angle is this two angle CBD, that's equal to CAD. These two angles are equal to each other. Okay, and again angle CBM equal to CME, angle CBM equal to angle CME, because they are complementary angle to each other. They are complementary angle to each other. Okay, same angles, complementary angle. So we can write down in the also we can write down this angle, that CME is the vertical opposite angle of AMF. So these two are equal in the triangle. This one in the triangle AFM. Now in a triangle AFM, we can say that AF equal to FM. Why? Because these two angles are equal to each other. So these two sides will be equal. And similarly, we can say these 4 angles are equal to each other. That's why we can say in this triangle, we can say this FMD equal to FDM. So the side FD is equal to FM. Now from these two, we can say that these two FM equal to FD. So AF equal to FD. This is our proof. Okay, dear students, I think you have understood this one clearly. Now your homework number is 2, your HW number is 2, and which one is your HW? Your HW number is 2, is like Theorem 11. So do your HW properly and submit it in every Saturday from 9 AM to 3 PM. See you again inshallah. Till then, Allah Hafiz.